right, we have one more day here on solving our radical equations that we learned in our last lesson for 9:30. It's nothing really new today. We're still going to be solving our equations that involve radicals and checking our answers for those extraneous solutions like we learned about last time. Today we're just going to look at a couple of different types of problems and just make sure that you're feeling really confident. So as a warm-up here, we're going to have to remember how we do this when we square radicals that are a little more complex. So those are your two warm-up problems. Go ahead and pause your video and check those out. Hopefully this first one wasn't a hard one. We tackled a lot of things that looked like this in the last lesson, but just as a review, remember square root and squared cancel out, right? So our answer is really 6x. It's the whole thing that's left on the inside, right? So just plain old 6x is our answer for the first one. Nothing crazy there. That was not a trick question. Number 2, however, the 5 is on the outside of the radical and the 3 is on the inside. So technically this is 5 times radical 3, right? And when I have an exponent outside of parentheses and multiplying inside, that means that I am going to distribute my exponent. So this is really like 5 squared times radical 3 squared. Right? I have to square both parts. I'm not just squaring the radical. I have to square both things on the inside of that parentheses. And that's because that 5 is on the outside of the radical. In number 1, both of those things were inside the radical, and so then that radical cleared it all out. But here I have to square both parts, so be careful of that. All right, so then 5 squared is 25, right? And the square root of 3 squared, those cancel out, so this will just be 3, but I'm still multiplying these things together. So this is now 25 times 3, which gives you 75. Now, we did do that. We did that when we were doing Pythagorean theorem, right? When one of our sides looked like that with a 5 radical 3 or something like that. So this isn't new for you, but it is something that we tend to forget occasionally here and there. So just remember that. In number 1, like if everything is on the inside of the radical, then when you square it, the radical just disappears. But like on number 2, if you have a number outside of a radical and a number inside, and you're squaring the whole thing, you need to square both parts, okay? All right, so let's think back to how we did these problems in the last lesson. So we're going to solve and then check for extraneous solutions. So the square root of 2x plus 1 is all on the inside, minus 3 is on the outside, and it equals negative 2. All right. Now, you may be thinking like, oh man, I see this radical equals a negative number. Something's probably going wrong. Be careful. Remember not to make any judgments until that radical is completely by itself. So the first thing that I need to do is move this 3 since it's on the outside of the radical. So since that's on the outside, I will have radical 2x plus 1 left on the left-hand side. Negative 2 plus 3 gives me 1. On the right. So I do not have a radical equals a negative number. So this is not necessarily a no solution. We'll have to keep solving and then double check to see if our answer still works. So my radical's all by itself now, so I can square both sides. I can't move anything else until I get rid of that radical. So I square both sides, square root and squared cancel out, so I get 2x plus 1 on the left, 1 squared equals 1 on the right. Subtract 1 from both sides to move this guy. I get 2x equals, 1 minus 1 equals 0 on the right-hand side. 0 is a number. Don't freak out. Let's keep on solving. Divide both sides by 2, and I get x equals 0. Now, this is not no solution. This is 0, the number, right? So I don't know that it's a no solution necessarily. I still have to check my work to see if I have any extraneous solutions. Maybe the 0 won't work, but maybe it will. So remember, the next step in the process is to check our answer. So on the left, I have a big square root sign. I have 2 times 0 plus 1 is going to be on the left. And then I have the minus 3 on the outside of the radical, and this is supposed to equal negative 2. So I'm plugging in that x equals 0 back into my original equation. Now don't resolve. Remember to use the order of operations. So I'm going to work on the inside of my radical here. 2 times 0 is 0, so I'll have the square root of 0 plus 1 minus 3 is on the outside, equals negative 2. 0 plus 1 is 1, so I'll have radical 1 minus 3 is supposed to equal negative 2. Square root of 1 is 1, so I'll have 1 minus 3 equals negative 2. It's looking good. 1 minus 3 is negative 2 equals negative 2. So yes, x equals 0 is a solution. So don't freak out when you get 0. It's okay. Check it just like you check anything else. Maybe it won't work, but 0 is a number, so it's a possibility that it could. Okay, that was a good review from the last lesson. Let's check this one out now. 3 radical 2x equals radical x plus 34. So I have a radical on both sides. Now we did one like this at the end of the last lesson, but I have a number on the outside of this one. So the number on the outside here is multiplied, right? 3 times radical 2x. And there's no number on the outside of the other one. There's nothing I can do to really get rid of that number. I can't move it anywhere. If I divide, it's just going to be on the outside on the other side, right? So since it's not adding or subtracting or anything like that, I can't move it. So I think I'm just going to have to go ahead and square both sides and see what happens here. Okay, so this will get rid of my radicals. Now remember, like our warm-up, this is multiplication going on here. When I have an exponent outside of parentheses with multiplication on the inside, I need to distribute my exponent to both parts. So this becomes 3 squared, and this becomes radical 2x squared, right? 3 squared is 9. Radical 2x squared, there the squared and the squared cancel, so I'll have 9 times 2x. Now I was kind of just working a little bit on that side just to kind of show you that. On the right hand side, the square root and the squared will just cancel out, and I'll have x plus 34 since there was nothing on the outside that I was squaring on the right. All right, now I'm going to keep going here. On the left, I have 9 times 2x. That gives me 18x equals x plus 34. So you don't necessarily have to show this step right here where like it's 3 squared and a square root of 2x squared. If you want to, when you're distributing that exponent, if you jumped straight to 9 times 2x, that's perfectly understandable. That would be a real big jump to jump all the way to the 18x. I think there's a really good chance that you would make a silly mistake in there when you're trying to do all of that work in your head without writing anything down. But I could see where you wouldn't necessarily have to write the 3 to the second and the square root of 2x to the second. For me, I like to write everything so that I can always go back and check my work and make sure I didn't goof anything up. But I was just letting you know that that would be an optional step if you wanted to. Okay, now I'm going to keep on going. So I'm going to subtract x from both sides. I get 17x equals 34. Divides both sides by 17. I get x equals 2. Now I need to check my answers for extraneous solutions, right? Still have to check here. So I'm going to go back to my original equation, 3 radical 2x. So 3 times radical 2 times 2 on the left, and on the right I have radical x plus 34, so it'll be 2 plus 34 on the inside of that radical on the right. Okay, remember order of operations, so I'll do 3 radical 4 on the left, and I'll have radical 36 on the right. Square root of 4 is a perfect square, so this is really 3 times 2 on the right. Square root of 36 is a perfect square. That gives me, on the left. And the square root of 36 on the right is a perfect square. I get 6. 3 times 2 is 6. So 6 equals 6. This is a good solution. X equals 2 is a correct answer. All right. So just remembering, like, if you have a number multiplied by one of those radicals on the outside, it's okay to square it right away. Just remember to square both parts. Last one we're going to do today, similar to the last one, but I've got a number on the outside on both sides. Go ahead and see if you can solve this one. All right, so if you wanted to, you could maybe divide both sides by 2, but I think I'm just going to go ahead and square both sides right now since I see that nothing is being added or subtracted on the outside of these two. So I square both sides. Now remember, on the left, I'm going to distribute that exponent. So I'll have 4 squared, which is 16. And then the square root of x minus 2 squared will just be x minus 2. If you needed to see that, it would be 4 squared times square root of x minus 2 squared. Those are going to cancel. 4 squared is 16. Okay, so again, you don't necessarily have to show that step, but you can if you want to. Same thing over here on the right. I'm going to distribute here. So this is really going to be 2 squared, which is 4. And then it's going to be the square root of 2x squared. Square root and squared are going to cancel out, so it'll be times 2x. So a little more complicated, a little more going on here, but nothing we can't handle, right? Okay, so I have 16 times x minus 2 on the left. I have 4 times 2x on the right. So on the left, I see I need to do a little distributing. So I'll have 16x minus 32. On the right, I'm just going to multiply. 4 times 2x is 8x. All right, now let's see. I'm going to subtract 16x on both sides. So I get negative 32 equals negative 8x. Divide both sides by negative 8. And I get 4 equals x. So my solution right now is x equals 4, but I need to make sure that I check for any extraneous solutions. See, maybe that one won't work. We'll see. Okay, so I'm going to go back to my original equation. 4 radical x minus 2, so this is 4 minus 2 on the inside on the left, equals 2 radical 2x, so 2 times 4, on the right. Okay, order of operations here, so I'll have 4 radical 2 on the left, and I will have 2 radical 8 on the right. Oh, now be careful. In fact, maybe even on the last step you could have done this, but I can simplify this radical. 8 is square root of 4 times the square root of 2. I see right there I could have done it, right? So this is really 2 times 2, radical 2. Square root of 4 is 2, comes to the outside. So it looks like we are going to be in luck. 4 radical 2 equals 4 radical 2. Yes, it does work. Okay, so just watch those. If you have a number outside of the radical, you're going to square both parts is the big idea from today. Otherwise, everything is the same as the lesson from before. So, watch for that radical to be by itself. You can't have anything added or subtracted on the outside before you square both sides. But if there's a number multiplied, okay, just be careful. Only do that when there's a radical on both sides, okay? And then don't forget to check your answer to make sure it works.